Hi, my name is Nathan Wilson. I'm from KCG. I did this work with Hal Finkel during a course at University of Chicago. It's about fixed point optimization in LLVM. So the normal optimization pipeline looks like this. You have some source code as input. It goes through a few passes, and you have optimized output. Magic. So some observations and problems with the pipeline. Anecdotally, generated code may be more performant when the whole optimization pipeline is run multiple times. So it begs the question, is this generally true? Then optimizations may also fight with each other by undoing previous changes done by one optimization and creating a new optimization which it thinks is better. So potentially this could lead to a cycle with them fighting with each other. And then when forcing multiple pipeline runs, some optimizations may be unnecessary. So if you keep rerunning these and maybe 2 or 3 out of 50 or whatever only make some meaningful change, then it's essentially a waste of resources. So then the last one is an optimization could produce a false positive, telling the pass manager that the code has changed when it actually didn't. This comes from the value from run on function when we're told via Boolean whether something was changed or not. So we created a new pipeline, new in the sense that it would go through the same passes, and at the end of it, if there was a change in the IR, we'd run the passes again. And at the end of it, we'd get hopefully an improved output. So some of the motivation and benefits about why to do this in the first place is to generate faster code. We want speed. We'd also like to have code generated via fixed point to be faster than the normal pipeline. So if we run it and some number of times, then hopefully the code when we run performance tests is better than it was before. We'd like to run the pipeline until there aren't any more changes in the IR. We'd hope to get smaller code size in general. And another benefit would be to have faster compilation times. So theoretically, you could run the pipeline some n number of times, say 10 or 20, and hopefully you get the same results. But again, what I alluded to before was that it may be unnecessary because many of the passes may not change anything. And then we'd like to really see if any of the optimizations fight with each other. So perhaps the compiler, perhaps we just hang when trying to compile code. That sort of give us an indication, or we'd like to assert at some point and figure out what's going on, to figure out which passes we're fighting with each other. So some of the actual findings what were the results from our investigations was that performance as a whole were plus or minus a few percent when running it on the test suite. In terms of code size, some things were a few percent better, but overall, when summing up the binaries generated, whereas that the binaries were 30% larger as a whole. And then a good thing that we found out was that in practice, we only needed a limited number of iterations. And in this case, it was no more than 4 on the test suite, and most only required 2. So for more information, come see the poster tomorrow. And that's it.